Okay, in this experiment what we will be doing is that we're going to be taking a battery, which is a cell. We know how much will be the voltage, so we know that's a 9 volts. You can also change it, so I'm going to change it here to 0 to start off with, but there's no, it's dead. I'm going to put a light bulb as one of the resistors. Let's imagine we don't even know that it has a resistance. It's the inside filament that we are interested in. And we're going to get some wires, connect it here. I'm going to put a switch as well. Okay, and I'm going to take my meter. I'm going to measure how much current is passing through this. So I'm going to connect this here, bring this here, and I'm going to connect this next side here to this side. Now the ammeter has been connected in series so that we can detect what's the current going through the light bulb. Alright, once I press here complete, then it should be completed. Because the cell is 0, it's dead, then we should have a 0 reading. So we have the reading as, let me make an Excel file here, a Word file, and so this will be our readings for our graph. Voltage, letter B. We're gonna have here current given by the letter here. About that. There. Okay. So we should have our table. So let's go back again. So we are here with our device. We're gonna be breaking the circuit, opening the circuit. We're gonna be increasing it here now to maybe 1.5 volts. That's the usual standard of a kilowatt should have. So I'm going to complete now the circuit and see what's our amperage. So we're going to be recording the amperage here. We're going to consider that this is 1.5 volts. So our voltage will be 1.5. And when I close this, I should get the reading on the amperage that's going through the light bulb. So I close it and I get that the amperage is 1.5, no, 0.15 amps. So that's good. So I'm going to keep open it again. I'm now going to change now the voltage. Since every cell should have 1.5, I'm going to put this here now to 3 volts. That's 3 volts. And so when I close this, I'm going to see what's our amperage. So at 3 volts, I get 0.3 amps. So I'm going to open it again. Look at the brightness also of the light bulb. 1.5 is going to be 4.5 as well. So we have the 4.5 here. We close it and we get the amperage of 0.45 amps. So 4.5. Notice the brightness of the light bulb as well. So I'm going to change it again. Change the light bulb to 6. And I change this to 6 now. I have here, remember the brightness, close it. So at 6 volts, it gets brighter and the amperage is 0.60. Now, we are using this method because devices were not available when we were supposed to have gone in. 1, 2. We are using this method because of time. We are using this method because of COVID precautions. And we are using this method because when we were supposed to have gone in Monday, we were not given the opportunity to go in Monday, as that day was already had to send out a letter to parents as well and all other things. So we're using this method here. Okay, so we have our readings now. So we can open it. So we can put our Excel file. And in an Excel file, you can create your graph, a line graph, between your X and Y column. So for this one, so in other words, for this lab here, I wanted to create a graph with voltage and amperage. And in this graph here, this will be an analysis and interpretation. Okay. So for this graph, what we are going to be doing, I want us to look at our observation, our diagrams, our precaution, our limitations, and conclusion. The observation, I guess we have to use the different values. So let's take those ones there as screenshots and let's save them. So this is one of them. Take a picture of it. We have that as one of our readings. That is going to be pasted in a Word file. That is going to be pasted also in your document. Okay, where you will have everything set as how you should. Right, so that will be one of our diagrams. As well, make sure you go back and let's change the voltage to 4.5. Let's make sure that we have all of our pictures of 4.5 so we can see what's our reading. Okay, remember our voltage is remaining constant, so we are not changing the voltage. So we have that one there. Okay, and then I'm going to change also our voltage to 3 volts, and voltage from our cell is not, I mean our voltage is decreasing, and well, we actually increase it, but I'm just taking the measurements and making sure that all of our pictures are there based on all of our readings that we have for this lab. So we decrease it from 3 to 1.5. We must also take into account when there is no reading from the cell itself. Okay, so there we go, and we have that picture as well. And then we have our last picture just to make sure, and that's to 0 volts, or when there was a break in the circuit. We can say also if there was a break in the circuit, then obviously there's no current inside of it. Okay, so we have that one there. So we have everything that we should have. Okay, for readings, yes, analyze shape of the graph. We have that one there as well. That should not be a problem. And then we should have our limitations, conclusions, and so forth. We from our graph that we are going to do, we will be interpreting many things. Okay, so proving Ohm's law, which is our key point here. Factors of which affect the resistance of a material. Not really factors. So we've got prove here. Proving that current is directly proportional. Okay, so that's our main point there. So we have this lab that we have done digitally